بسم الله الرحمن الرحيم. أبنائي الأعزاء طلاب الصف الثالث الثانوي، بنرحب بكم مجددا، وإن شاء الله يكون لنا لقاء جميل النهاردة إن شاء الله بإذن الله، ويكون لقاء مثمر ونستفيد منه، ونكون ذاكرنا اللي فات، ونكون الجزء اللي احنا أخدناه نكون ذاكرناه. بسرعة هنراجع الكلام اللي احنا قلناه عشان نكمل ونتواصل مع بعض. احنا خدنا المرة اللي فاتت النومنكلاتشر، قلنا النومنكلاتشر we have basis of nomenclature: alkanes, ميثان، إيثان، بروبان، بيوتان، بنتان، هكسان، هبتان، أوكتان، نونان and ديكسان. This is the number of carbon atoms. It is very important and we will use it in different nomenclature. Today we will firstly start by nomenclature of some compounds as a type of revision. First one, we must use different colors of pen or pencil to help you for a choice. Again, IUPAC system. Firstly, choose the longest continuous chain of carbon atoms. Choose longest continuous chain of carbon atoms. Then numbering the carbon atoms from the nearest end to the branch. As example, first one, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We can get this series 1, 2, 3, 4, 5 as continuous chain. Why we choose this chain? Because this chain contains large number of branches. We can numbering from here or from here as same, because methyl at carbon number 2, ethyl at carbon number 3. We can start from here 1, 2, 3, 4, 5. Pentane. Before writing pentane, bent means 5 carbon atoms, and this compound is saturated compound. We have a branch at carbon number 2, 2-methyl, 2-methyl, 4-methyl, 2,4-dimethyl. We can write it 2,4-dimethyl. And we have ethyl at carbon number 3, 3-ethyl. Oh, now we must arrange according to alphabetic. So we must write 3-ethyl firstly, 3-ethyl, 2,4-dimethyl. And the main series is pentane. This is very important. Arrangement according to alphabetic. Alphabetic E before M. So we write 3-ethyl. 3-ethyl means the position of ethyl at carbon number 3. 2,4 the position of methyl, dimethyl, because they are similar, and the main chain is pentane. Another example, number 2, we can choose 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We can get this chain as U shape. It is new for us. We will start to numbering from this end or this end. This end is nearly to the methyl. So 1, 2, 3, 4, 5. Pentane. At carbon number 2, methyl. 2-methyl pentane. Number 3, we have CH3, CH, C2H5, 2. We can write this compound in structure form. Put C in center. Hydrogen and methyl, CH3, 1-ethyl, C2H5, and another C2H5. So we can get this series: CH3, CH2, C2H5, CH, CH2, CH3, CH3. To write the nomenclature for this compound, we will choose the longest continuous chain. Numbering from the nearest end to the branch. 1, 2, 3, 1, 2, 3. As same. So you can choose each one you love. Number 1, 2, 3, 4, 5. Methyl branch chain. 3 methyl pentane. 3 methyl pentane. It means at carbon number 3 group of methyl. 3 methyl pentane. We have some examples as we put inside it group of halogens as example 1, 2, 3, 4 and CCl3. CCl3 not from the chain, it is the branch. We can write it C 1, 2, 3, 4 H and Cl. Choose longest continuous chain. 1, 2, 3, 4. Carbon. Longest continuous chain of carbon atoms, not Cl. We will start numbering from this end because it have 3 chlorine. 1, 2, 3, 4. 4 bute. At carbon number 1, 3 atoms of chlorine. 1, 3-chlorobutane. Again, it is very easy, not difficult. And you can try again different times. Number 1, choose longest continuous chain of carbon. Number 2, numbering from the nearest end to the branch. Number 3, put the name of each branch. We have 3 chlorine. 1, 2, 3 trichlorobutane. Another example, 2 carbon. 1 carry bromine and chlor, and the other carry 3 atoms of fluorine. Choose longest continuous chain. We have 2 carbon atoms. This is our chain. We ask ourselves, start from here or from here. Carbon number 1 carry 3 atoms of fluorine. So we must numbering it 1 and the other is 2. Why we start from here? Because it have 3 branches, but the other have 2 branches. And we must put according to alphabetic. 2 bromo, 2 chloro, 1 trifluoro. Why we start by 2 bromo? B before C before F. So 2 bromo, 2 chloro, 1 trifluoro, ethane. 2 bromo, 2 chloro, 1 trifluoroethane. According to alphabetic, B before C before F. And our chain is ethane. Another example, CH3, CH, CH2, CH, CH3, CH3, Cl. To choose the longest continuous chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. As same, so easily to get the straight line. We start for numbering from this end or from this end. Chloromethyl, C before M. So we must start from here. 1, 2, 3, 4, 5. Pentane, 2 chloro, 4 methyl pentane. It is easy to do a nomenclature for alkanes. Firstly, we must keep mis, is, prop, but, and bent, methane, ethane, propan, butane, and we use it with the IUPAC rules. Again, choose longest continuous chain. Number 2, numbering the chain from the nearest end to the branch. Arrange branches according to alphabetic. Which one which we can start? As example, B, C before M. And as ethane, we can arrange according to the alphabetic. Then we will study alkenes. Alkenes as the first series. Before studying it, we need some concepts which we will use it again. Number one, water is a polar solvent. What's meant by polar solvent? Polar substance in general. Polar means this molecule contains one from the four, NOFCl. NOFCl, they are elements which have higher electronegativity. The presence of one of them in a compound or in a molecule make it polar molecule. As water, H2O. Oxygen, higher in electronegativity than hydrogen. It will attract electrons of bond to itself. So it will carry partial positive, partial negative. What's meant by partial? Small charge. Why we doesn't put positive or negative? Because no lose, no gain. There is a share between hydrogen and oxygen, but electrons move towards oxygen because oxygen is higher in electronegativity than hydrogen. So we said that water is polar compound due to presence of oxygen is higher in electronegativity than hydrogen. Number two, from the concepts which we will need, sigma bond and pi bond. What is the difference between them? Sigma bond and pi bond. If we get an example, ethylene have hybridization from type of sp2, and another atom of ethylene have sp2, 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 and there is an orbital bz without hybridization, overlapping between four atoms of hydrogen with ethylene. What is the type of overlapping? If the overlapping head by head, it will form type of bond from sigma bonds. What's meant by sigma bond? Sigma bond, it is the bond formed due to overlapping head by head between orbitals. So it is very, very strong and difficult to broken. Sigma, and sigma between two carbon atoms. But BZ with BZ, they will be overlapped side by side and formed by bond. By bond formed by overlapping side by side between orbitals. So, some questions. How many sigma bond in ethylene? 1, 2, 3, 4, 5. 5 sigma bond. How many pi bonds? 1 pi bond. Another question. How many sigma bond between two carbon atoms? We have two carbon atoms. We have 1 sigma bond between two carbon atoms. This is very important to know the differentiate between sigma bond and pi bond. We will repeat it and use these words when we explain the properties of alkanes, alkenes, and alkynes. Sigma bond, type of bond, difficult to broken. It formed due to overlapping head by head of orbitals. But pi bond, type of bond formed between two orbitals were overlapped side by side. What is the difference between them? Sigma, difficult to broken and need high amount of energy, but pi, easily to broken and easily to separate between them. And makes the compound more active. Pi bond makes the compound is more active. Firstly, we will study alkanes. What's meant by alkanes? We can repeat together what we said about alkanes. Alkanes are saturated hydrocarbon. Their general formula CnH2n plus 2. They are found in carried oil. Carried oil is a complicated mixture which have large number of compounds mixed together. Alkanes are found in carried oil. We will study, طبعا we can separate between them by using dry distillation أو fractional distillation. Fractional distillation. We can separate between them by using fractional distillation. They separated according to the boiling point of each compound. Firstly, we will study the methane. Methane is the first member of alkanes. It is the simplest form of organic compound. It is the simplest form of hydrocarbon. Why it is considered as a simplest one? Because it contains one carbon only. Firstly, it have one carbon only, methane, simplest form. Methane represented more than 90% from the natural gas. Natural gas, the gas which we use in house as a fuel. Methane is called gas of swims. Why it called gas of swims? Methane produced from decaying of remains of living organisms in swims. So it appears as a bubbles, produce methane. So it can fire. How we can prepare methane in lab? To prepare methane in lab, from the apparatus in front of you, we have a test tube. We put inside it anhydrous sodium acetate. Anhydrous sodium acetate, CH3COONA, is the salt of sodium, sodium acetate. It converted from acetic acid. We react it with soda lime. What's meant by soda lime? Soda lime is the mixture of sodium hydroxide and calcium oxide mixed together. In equation, we put sodium hydroxide and calcium oxide above the arrow because it acts reduce the melting point of the substances. What happened during the reaction? We must write chemical equation and use it as a mathematical equation. CH3 square from here to here, hydrogen with CH3 formed methane, CH4. The remain 2 atoms of sodium, Na2, 1 carbon and 3 oxygen, Na2CO3, sodium carbonate. The apparatus is very important and we must know how we can draw it. By using test tube, put inside it anhydrous sodium acetate with soda lime. We will ask a question. Why we didn't put sodium hydroxide only? Why we use calcium oxide? We use calcium oxide to reduce the melting point. It will produce methane and sodium carbonate. Gas produced will make a bubbles and collected above water because methane gas, its density is less than water and it insoluble in water because it is non-polar compound. So it will evolve and displacement water. This area will fill by methane gas. What is the general properties of alkanes? Alkanes, to study it, number one, we will study the physical properties. Physical properties, number one, alkanes exist in the 3 physical states, solid, liquid, and gas. We must know this fact. Gases, which have group of compounds from C1 to C4. What's meant by C1 to C4? Methane, CH4, 1. Ethane, C2H6. Propane, C3H8. Butane, C4H10. This means from C1 to C4. Methane, ethane, propane, butane. This group are found in form of gaseous state. With increase the number of carbon, it becomes liquid from C5 to C17. As examples, gasoline and kerosene. Gasoline which used as a fuel for car. Solids more than 17. If we have more than 17, the molecule becomes bigger and it will form in solid form as wax or grease. Melting and boiling point of alkanes increase with increased molecular formula, with increased number of carbon atoms. As carbon atoms number increase, the boiling and melting point of compound will be increased. Alkanes are non-polar substance because it doesn't contain anyone with high electronegativity. So it doesn't be soluble in water, but alkanes are soluble in organic solvents as benzene, ether, alcohols, but not soluble in water. Alkanes are inactive compounds, so we can cover metals by wax or grease to protect it from rusting, to protect it from react with atmospheric air. So car spares are covered by grease to protect it from reaction of water vapor in atmospheric air. Chemical properties of alkanes. Firstly, burning or combustion. What's meant by burning or combustion? Reaction and burn in presence of oxygen. Rapid oxidation. We must know it very well. If we get carbon dioxide, if we get methane and burn it with oxygen, methane, CH4 plus O2, burn in presence of oxygen, it means rapid oxidation. Carbon get oxygen, produce carbon dioxide. Hydrogen get oxygen, produce water vapor. So we can put an rule and produce large amount of energy. It is an exothermic reaction. So it used as a fuel. Methane burn in presence of oxygen, producing carbon dioxide and water vapor. This is the rule for all hydrocarbons. Hydrocarbons contain carbon and hydrogen, burn in presence of oxygen, producing carbon dioxide and water vapor. We will ask a question. All as same? No, according to balanced of equation. We can balance equation. We have two balance equation. CH2O4 plus 2O2 by burn produce carbon dioxide and the 2 water molecule and the large amount of energy. So it used as a fuel in houses. Number 2, from the second properties of the chemical properties, thermal catalytic process. Thermal catalytic cracking process. Thermal catalytic cracking process change long chain compound into small chain. Why? Because long chain is less use, have no importance, have no use. But if we make it in small chain, we can get more use. As example, octane C8H18, we make thermal catalytic cracking in presence of high temperature and pressure and in presence of catalyst. It will octane. We know why octane? Because 8 carbon atoms. It will produce C4H10 plus C4H8. What is the difference between them? C4H10 butane, C4H8 butene. What is the difference between them? According to general formula, butane CnH2n plus 2. According to general formula, CnH2n. So it is from alkene and the other from alkene. Octane, by thermal catalytic cracking, we can make from it butane and butene. This process is very important because it will transfer long chain into small chain. Less use to more use. More important, more use, less use. It is the thermal catalytic cracking. Thermal catalytic cracking. Then we will study the reaction with halogens. Again, the chemical properties of alkenes: burning, combustion, reaction. Burn methane in presence of oxygen, produce carbon dioxide and water vapor and large amount of energy. Number 2, thermal catalytic cracking process, which we get alkane with long chain and make a thermal catalytic cracking to make it from less use to more use. Convert octane into butane and butane, as we see in the reaction. Another reaction with halogens. Reaction with halogen: methane CH4, alkane, nonpolar, and all bonds are from sigma type, difficult to broken. If we want to react it with chlorine, we need very high amount of energy, 400 degrees, or in presence of UV. Or what happened? This compound, all bonds are single from type of sigma. So the reaction will be substituted reaction. Get hydrogen and replace it by Cl. Substitution reaction. Cl and H with Cl forming HCl. Write the name for this compound. 1. Methane. Have chloromethane. Again, the reaction will complete CHHCl with ClCl. Means Cl2. 400 degree or UV, ultraviolet rays. What happened? It will replace hydrogen with another atom of chlorine, forming CHHCl plus HCl. What is the name of this compound? Methane and 2 chlorine, dichloromethane. The reaction will be completed in another step. CHHCl with ClCl, 400 degree or ultraviolet rays. What happened? It will substitute another hydrogen atom with chlorine forming HCl, and Cl will replace it. CHCl trichloromethane, and its common name is called chloroform. Chloroform. It used as antiseptic substance for surgical operations. But we stop to use it because its dose can't be accurately, so it leads to death. So we must stop it now. We didn't use it. Then the reaction will be complete. CHCl plus ClCl, 400 degree or ultraviolet rays. What happened? Last hydrogen atom will be replaced by Cl. It will form CCl. This reaction need to draw it by your hand, step by step. You will remember it in exam, and easily by using a colored pencil. It is very easily for you. Tetrachlorocarbon. This is the reaction of methane with halogens with chlorine. The type of reaction is substitution reaction. We substitute step by step. Hydrogen atom go out and the chlorine atom enter, replace it in the molecule. Then we will study this part and it is very important for us. The economic importance of halogenated derivatives. Economic importance, its uses, it's important. We must study it very well. Number one, chloroform, as we draw now in equation, CHClClCl, trichloromethane, CHCl3. It used anesthetic in surgical operations, but now stopped to use because it is not safe. Number two, halothane. Halothane, carbon, B, bromine, chlorine, hydrogen, fluoro. It contains all halogens. To make its nomenclature, 2-bromo, 2-chloro, 1,1,1 trifluoro. We will ask ourselves why we write bromo and chloro firstly according to alphabetic. 2-bromo, 1, 2. 2-bromo, 2-chloro, 1,1,1 trifluoro. It used as antiseptic because it is more safe than chloroform. Number 3, 1,1,1 trichloroethane. It used in dry clean process. Another point is very important, Freons. Freons, it is a chemical name of halogenated compound CF4 or CF2Cl2. Freons is used in cooling system, in refrigerator, in air conditions because it is low price and non-corroded for metals, and we can liquefy it and no poison. But it have an disadvantage because it causes decaying for the ozone layer, so we have a protocol to stop using of freons. The economic importance of alkanes. Number one, we can get black carbon. Note this equation carefully. Methane, when we heat it at 1000 degrees, no air, because in air it will produce carbon dioxide and water vapor, but no air. At 1000 degrees, it will break bonds and produce 2H2 and C. C is called divided carbon. It used in car tires, black ink, paints, and polishes. Number 2, from the economic importance, water gas. If we pass water vapor over methane at 725 degrees in presence of catalyst, it will produce mixture of carbon monoxide and hydrogen, CO plus 3H2. This equation, we studied it before in chapter 1. It is produce water gas, which used as a reducing agent in matrix furnace. Alkanes, from the subjects which we easily to study it, and we can repeat it again several times to be more and more easily. بكده طبعا يبقى احنا عندنا الالكينز سهله جدا في التعامل معاها، وان احنا نعيد ونزيد فيها ونذاكرها ونراجع، والمعادلات مش حفظ. وانا سعيد جدا بلقائكم، وان شاء الله يتكرر اللقاء نكون استفدنا ونكون يعني حسينا ان احنا يعني حصلنا حاجه من الموضوع اللي احنا كنا بنتكلم فيه. ما ننساش طبعا الشير والسبسكرايب، وطبعا لو حد عنده اي كومنتس ولا اي حاجه يسجلها عشان نعرف نتواصل مع بعض. شكرا والسلام عليكم ورحمه الله وبركاته.